Chang, one of the thank you. And one of the co-organizers of the IRES seminar series this year. Before we get started, I just wanted to start with a land acknowledgement to recognize that we are gathered on the traditional, ancestral, and unceded territories of the Musqueam people, and to express our collective appreciation for this opportunity to work and to learn on these lands. I have the great pleasure to introduce our speaker today, Dr. Laurie Daniels. She's a professor in forest ecology, the Department of Forest and Conservation Sciences, where she directs the Tree Ring Lab. Laurie's research concerns the impacts of natural and human disturbances and climate change on forests. One of the really important aspects of her work, I think, is that she does it, excuse me, about this feedback. She does it in collaboration with a lot of partners from all levels of government to, pardon? Is it me? Okay, let me try that again. This is in partnership with all levels of government, environmental organizations, forest management companies, First Nations, among other partners in her work. I won't read through her entire bio. It's lengthy. She has received many awards. I just want to highlight one just this year. She was awarded the 2023 Distinguished Researcher Award from the Association of Fire Ecologists. So on the extremely timely topic of wildfires, let's welcome Laurie Daniels.
Okay, we're going to see if we can juggle the room, the computer, the video that doesn't quite work the way we intended. It's my pleasure to be here, and thank you very much for the invitation to be a part of this speaker series. I was trying to be evocative of it here. How to create record-breaking wildfire seasons in BC. I don't know about you, but I'm feeling a little bit overwhelmed by the amount of wildfire that we've experienced in recent years. And so I wanted to share with you some of my reflections and thoughts about what is creating these megafires, what are their drivers, and more importantly, what do we do as citizens to try to adapt and be prepared and coexist with future fires. I want to first acknowledge that I have this fantastic research team who have been working with me since 2015 on a whole bunch of the results that I'm going to share with you today and some of the insights. And so a big thank you to everybody in our lab and our labs with whom we kind of have cross-pollinated with multiple labs over in the forest and conservation sciences and forest resource management departments. So I do want to point out that much of what I'm sharing with you today comes from this amazing team that I get to work with on a regular basis. And also a big thanks to our collaborators, our partners in the funding agencies. We work, as was said in the introduction, we work from individual communities, First Nations communities, municipalities, community forests, right up through multiple levels of government and non-government organizations. And their collaborations and partnerships are essential to allow us to do the work that we do, but also to see the results of that work hit the ground running. Now, I have a quick question before we go. Is anybody here in the room or those online as well? I want to acknowledge that many of us have been impacted by wildfire, and you might have been impacted, forced from your home or from your community. You might have loved ones who are out of their homes or out of their communities as I speak. And I want to just acknowledge that some of what I'm going to share with you are videos of fires burning in British Columbia this summer. And they might have some impacts on some of you. So if you need to just look away to protect yourself, please feel free to do so. And for those online, I'm going to stop sharing just for a moment. We have to do a switch to get the video to run for all of us to view. There. There you go. Oh. Oh, we're still on the slides in the room. Yeah. Yeah. does this to me in class too. You know, you set up the video, it's all ready to go, and then you put it on the projector and half the video's gone and all the important bits you wouldn't get to see. So please bear with us for one more moment while we try to see if we can't get this to work properly. There. Okay.
Still seeing the video on Zoom.
Okay, fantastic. Thank you. Okay. So what we're seeing here is the McDougall Creek fire, which ignited up in the hill slopes above West Kelowna early in August. And on August 17th, a cold front moved through the province and brought with it, after the heat that had dried the forests, extreme wind. And as you can see, it carried the fire. Fire embers carried, landing on the ground, spotting the fire front, catching up to those spots and burning at very high intensity. These are dry ponderosa pine and Douglas fir forests. Embedded in there are the neighborhoods of West Kelowna. The West Kelowna fire chief described this fire as battling 100 fires in one night. And sadly, 80 homes were lost by the end of this 12-hour fire run. So this blow up was driven largely by the extreme fire weather, but also what I want to convey to you today is the importance of understanding the condition of our forest and contributing to these fires. So we'll switch back to the PowerPoint, and I want to point out that there's been lots and lots of discussion in the media and social media. Oh, there we go. There we go. I'll get back to Zoom with everybody. Who knew it would be this complicated? Okay. Let's get those slides caught up now. Okay. So the question has been about these mega fires, these fires that are burning under extreme conditions, difficult to control, with huge ecological and human consequences. And the McDougall Creek fire is one of 2,200 that burned in our, almost 2,200 that burned in our province this summer. We've been in a state of emergency for much of the summer. We've had lightning ignitions, thankfully swamping human ignitions. We really limited the number of human ignitions through good communications this year. But during these extreme weather events, thousands of lightning strikes, igniting hundreds of fires simultaneously, creating conditions that resulted in tens of thousands of people on evacuation order and alert. Nationally, we've burned an astounding 17.5 million hectares. And here in BC, 2.5 million hectares, which is almost double the record that we set in 2018, which was dumbfounding in 2018. The largest fire on record, the Donnie Creek fire, ignited in May. It's approaching 600,000 hectares in size and will probably burn through the winter. I expect we'll see it continue to burn next spring. With thousands of firefighters out on the land, there's still almost 400 fires burning as we speak, and more than 100 that are out of control. So what is driving these? You know, social media gave me all sorts of insights. It might have been lasers from space, or it could have been really well-timed arsonists who have something that they're angry about, managing to get to the most remote places in Canada and simultaneously start fires. But I'm actually going to offer that maybe it's simpler. It's the elements of the fire behavior triangle, that it's weather fueled by climate change, that it's fuels fueled by a century of change, interacting with the topography, this mountainous topography that we call home here in British Columbia. So of the three, topography, this is kind of our geography and our geology of place. And of the three, it's the most stable over the time period that we're concerned about wildfires. Weather, of course, is varying across all time scales. It determines our fire danger. And it also determines whether or not fuels will ignite. Anybody who's tried to start a campfire with wet wood will know that unless your wood is warm and dry, you're not going to get your fire going. But if you get that fire going and you add fuel on top, you can transition your campfire to a bonfire in relatively easily. Now, our weather conditions, of course, vary daily and seasonally and from year to year. We've seen some alarming trends in the last 20 years, and here I'm bringing up Firestorm 2003. Exactly 20 years ago, we were in this situation where we were recovering from what at that point had been an epic fire season where just over 250,000 hectares burned. And quite frankly, if we could go back to a fire season with 250,000 hectares, we'd be grateful. In the last 7 years, we've had 4 record-breaking fire seasons, burning over or up to 1 million hectares, and this year almost 2.5 million hectares. And they're burning under extreme fire danger across the entire province. These maps are showing us the fire weather conditions for stations interpolated to give us the fire danger map for the whole province. And it's a heat map. So the redder or warmer the colors, the more extreme the fire danger. And you can see in August of 2017 and 2018, the peak of the fire season, we had excessive fire on the land. Early July 2021, driven by the heat dome, and early this spring in 2023, we had high to extreme fire danger over much or all of the province, and ignitions occurring very early in the spring, a hallmark of climate change, earlier starts to fire seasons, and those fire seasons lasting with deeper droughts at the peak of the summer. My colleagues and I have been collaborating, and the team up at the Northern Forestry Centre for Natural Resources Canada have worked with us to do some analysis to take a look at the trends over the last century in fire in BC. And so it's true that the number of fires has decreased. And so that's our bottom left graph. You can see there was more fires being counted and occurring on the landscape up till the 1940s. And then there's been this downward trend. The break point occurs in the 1940s, but it's a kind of a non-significant downward trend in recent decades. The area burned also showed a significant downward trend through much of the 20th century, but an abrupt break in the early 2000s. When we looked at the various climatic variables and looked across a whole suite of attributes that we know feed fire weather, we discovered that in fact, climatic moisture deficits, the droughts, driven by high temperature and low precipitation availability, well, that moisture deficit had been decreasing through time and abruptly changed around 2000, late 1990s for summer and early 2000s with a significant break point and an abrupt increase starting in the early 2000s in spring. So with moisture deficits increasing, driven primarily by warming temperatures and then insufficient precipitation to offset that increase in temperature, we have increased evaporative demand, driving drought, which is increasing fire activity and leading to a significant increase in the area burned. So we've been able to link then the mechanism, the weather patterns, the changes that we've seen in these weather variables, and ultimately the outcomes in terms of fire. Now in our fire behavior triangle, we'll come back, we've talked about topography and weather, and the influence of climate driving warmer and drier conditions and climate deficits. The third I want to point out are the fuels. And of course, they vary spatially from one forest to the other, and they change through time because forests are dynamic systems that are undergoing all sorts of change, human-induced change, natural change, and they undergo changes after these disturbances that influence the fuel availability on the land. Now, of the 3 axes, I want to point out that it is fuel that we have the greatest control over. And that's both in terms of our historical legacies, but also looking forward to solutions and how do we adapt to a warming climate with increasing abundance of megafire. Now, I wouldn't be a true scientist without pointing out, or a true ecologist without pointing out, there's all sorts of interactions as well. So I'm going to give you a little wildfire 101 here, where we talk about fire regimes and how fuels, weather, and topography interact to drive the way fire plays out on a landscape. And across the x-axis here, I'm giving you an environmental gradient from very dry to very wet ecosystems, and I've given you the names of some systems. And I'll point out that in the deserts, low productivity means there's very little biomass, can't carry fire, but it's hot and dry and combustible. On the far end of the spectrum, in our coastal temperate rainforests, abundant biomass, but given the climate conditions, they're generally wet and inflammable. It's the Goldilocks effect in the middle, in our grasslands, open woodlands, and dry forests, where we get the interaction between fuel availability and combustibility, leading to a really unique fire regime. So historically then, we see that fire frequency was greatest at that midpoint, but the severity of those fires was lowest. So imagine in a grassland open woodland, fires are burning frequently and they're accumulating fuels in the short interval from one fire to the next, but it's not sufficient to create an intense fire. And so we end up with a low severity fire as a result that maintains the system. The trees survive, the understory plants are adapted to that low severity regime. When we move out to the extremes, and I'll go along the forest gradient as we move up in elevation towards higher elevation forests or our northern forests that are more mesic, or into our coastal forests, we're into systems where it takes longer time for that biomass to accumulate, long intervals between the fires. And because we have to wait for an extreme weather event to dry them sufficiently to burn, we get long intervals from one fire to the next. It's a low frequency, but a high severity fire regime. Let's think about how climate change will influence this. Climate change asymmetrically changes the combustibility of the fuels. It increases the dryness or the flammability of the fuels on the wetter end of the spectrum, increasing fire risk. And so we see then increasing fire occurrence and increasing fire frequency in those more mesic forests first. I actually think this summer is a really good example of that playing out across the Canadian landscape. May and June, Canada was described as the epicenter of heat on the globe. We had record-breaking temperatures for both months in Canada. We ended up with very dry conditions across many of our systems. We had ignitions occurring on Vancouver Island and Nova Scotia. We had ignitions in the northeast of the province up into the true boreal forests, and then across all of boreal Canada with extreme fires still burning in the Yukon and Northwest Territories today. So the importance of this drought and climate effect becomes really important in a weather or climate limited fire regime, as we see in more mesic ecosystems. So let's come back and think about a second way in which climate change might alter our forests and fuels, and that's through tree mortality. We can get drought and high temperatures crossing physiological thresholds, causing tree mortality. We've also seen weather and climate interacting with our forests to drive alterations to disturbance regimes, like mountain pine beetle. And so we see these begin to accumulate on the landscape, and as a result then, with increased tree mortality, we increase the fuel hazards or the amount of fuel available to burn. And that ultimately pushes up the fire severity curve. And so we see that often across a whole range of elevations. I think the heat dome of June 2021 is an example of where this is played out in our British Columbian context. The extreme heat associated with the heat dome affected some of our driest forests, the epicenter, of course, being Lytton, which tragically burned on June 30th after reaching a temperature, an astounding temperature of 49.6 degrees Celsius, exceeding the record, by the way, even for Las Vegas, Nevada. So following that heat, we saw the forests in the surrounding landscape, even at low elevation in the Kamloops region, in the Lillooet region, in the Caribou, Southern Caribou and Northern Okanagan region, all susceptible to fire and burning, these mega fires that were tens of thousands of hectares and burning often at high severity. The concern for me is that 20 years of tree ring studies in these landscapes tell me fire didn't work like this historically. We've had the pleasure of working on territories of the Secwepemc people, of the Syilx, of the Ktunaxa, had opportunities to collect fire scar samples from remnant wood, logs and stumps and snags, of ponderosa pine, of Douglas fir, of Western larch, all thick bark species that can resist surface fire when they burn. And what we find embedded in the tree rings are these scars. Instead of the rings being those concentric circles that we can count to figure out how old the trees are, here you can see the anomalies in the tree ring patterns. Each of those swirls is marking the year when a surface fire swept past this ponderosa pine and damaged its cambium, leaving a scar, but the tree survived. This particular tree survived 52 surface fires between the late 1300s and the late 1800s. It was sampled on the Tobacco Plains, Yakan Iqanuktliut of the Tanaha territory. We can take these tree ring samples and we translate them into these charts. So here, this is a chart from the Caribou region, from the Alex Fraser Research Forest. And each horizontal line represents a plot in the forest. Each triangle is marking the year in which a surface fire scarred but did not kill the trees within the forest. And as you can see, there's a lot of scars out there. The fires were burning once every 10 to 20 years on average in our dry forests in British Columbia. We know that they were in part lightning ignitions, but they were supplemented by Indigenous fire stewardship, the use of fire to cleanse the land in a reciprocal relationship of give and take. I've learned from Secwepemc elders that they would give fire to the land, and in return, the land would provide the fire-adapted plants that were the foods, medicines, and important for ceremony. So those fire regimes had been burning for centuries to millennia to time immemorial. They left or they created open forest contexts where we had grasslands interspersed with woodlands and forests across a diverse mosaic on the landscape. And they kept the fuels low with these grasslands and open forests being maintained by those frequent surface fires. The red bars show the fire-free intervals at each of those sites. Now remember, fires used to burn once every 10 to 20 years, and these sites have gone decades to more than a century since the last fire scar formed. And so what it's telling us is the disruption of that surface fire regime, in part because we removed Indigenous fire from the land, in part because we changed land use for agriculture, for ranching, for industrial forestry as part of European settlement. But in part too, because our European-based society has a phobia against fire. We have had policies in place for decades that allowed us to both detect and suppress fires very efficiently. And in that time then, we have allowed trees to begin growing back into that landscape, increasing the fuel loads. We've homogenized broad landscapes, making them susceptible to drought and insects and disease. Mountain pine beetle affecting 19 million hectares of forest in British Columbia. And I can't let our forest practices off the hook. We're here on the Stucked House territory near Bonaparte Lake. And here's a satellite image from 1984. And then we introduced industrial forest management, the harvesting and cultivation of trees back on these sites to try to maintain sustained timber harvest and timber yield, but with consequences to the patterns in the landscape. And then we had mountain pine beetle invade into this land, and we had high degrees of mortality. And so the response across much of British Columbia, where we were able to, close enough to a mill, economically viable, we salvaged the dead trees. And so the impacts on this landscape, the cumulative impacts caught up with us very quickly. This landscape burned in 2018. It burned over areas that had recently been harvested, that had been harvested decades before. It burned through old forest as well. So although it looks like it's been fragmented, which it has been on one level, in many of those recently harvested patches, there was debris left on site, which was highly flammable, and trees were planted into that highly flammable material. And so when fire burned through, it took not only mature forests where it's clear there would be lots of fuel, but it also burned through cut blocks where there was abundant fuel on the ground, dry and desiccated, and seedlings growing up amongst it. So we've lost a generation of new trees, as well as our old trees in this landscape. And the fires were severe. They burned as crown fire. And when we map that severity and ground truthed it, we see that much of it was at high to moderate severity in a landscape where especially at the lower and moderate or in mid elevations, we find lots of fire scars embedded in trees that are now scorched and dead. So a significant change to this fire regime. So I've outlined for you then changes to this land that lead us to conclude that urgent change is needed, transformative change, so that we can move away from this era of mega fires, which is in part fed by climate change and the extremes in temperature, but also by many of the choices that we have made in over decades, thinking that we were protecting the forest from fire, when in fact we accumulated fuels. When we thought we were creating a sustainable economy and timber yield, without realizing the consequences as we scaled up to the landscape from the patch level where we were harvesting and regrowing trees. We've created low resilience both to our ecosystems and very vulnerable communities embedded in them. So let me pose to you some solutions that I think are directions that we can take that can counter the choices that we have made over the last century. The kinds of choices that we made, many of them were management choices that benefited our society, and we're now realizing there were unintended consequences. And so let's reverse engineer those and rethink how we can act on this landscape to live more sustainably and coexist with fire while adapting to climate change. So this might seem counterintuitive to some, but in fact, diversifying wildfire management is key. Letting fire back on the land under cooler and wetter conditions, the years when we don't have fire or extreme fire danger, but allowing fire to burn in that more low intensity, low severity impact, so that we can diversify those landscapes that have not yet been impacted by these major weather and climate-driven disturbances. Part of the solution is using ecocultural restoration of fire, working with Indigenous knowledge holders to reintroduce fire onto traditional territories and land, using prescribed fire as part of our forest management toolbox. And where it's unsafe because the fuels are so overloaded in many of these systems, using innovative silviculture, thinning the forest to remove the small, dense trees that have ingrown in absence of surface fire. Let's remove those fuels, restore the structure of the forest, reduce the flammability of that forest, and then reintroduce the ecological and cultural fire to restore other aspects of the ecosystem and its function. There's many things we need to diversify our forest management to achieve resilience. And that's going to happen at landscape, stand, and right down to individual tree choices. There are changes underfoot with the Ministry of Forests, and some of them I'd like to see move much quicker than they are today. And I'd be glad to answer questions about these particular topic at the end. I think there's many ways that we could be much more innovative. I'm going to take a few minutes to just transition, because I think this is important, especially in the context of the fire that we watched at the beginning of this presentation, burning into the suburbs of West Kelowna. We know in British Columbia, there is 5.5 million hectares of forests surrounding communities around this province. And embedded in those forests are high fuel loads, in part because of fire suppression, forest health issues, and some of our forest management in the past. And so making choices to proactively manage those, to reduce fuel loads by taking dense forests and thinning them out. If we can use prescribed burn in concert with that to reintroduce surface fire as part of the function, makes these ecosystems not only restored from an ecological process perspective, but what our modeling tells us is it reduces the risk of an active crown fire spreading up into the canopies and spreading treetop to treetop. Instead, it changes forest structures so that surface fire would be sustained and fire can't spread up into those canopies to burn and kill the trees. Our efficacy studies with modeling have proven on the ground to be effective. Here's the community of Logan Lake, where their community forest had fire burn within meters of homes. And our research plots established in April of May of 2021 burned in August of 2021. And we re-measured them in October of 2021. And what we found is in the top where there was no treatment had taken place, the forest was scorched, burned to mineral soil, 100% of the trees were killed. Whereas in the areas where fuels mitigation had happened to reduce tree densities and to mitigate material on the ground, we had a much lower mortality of the trees. Canopies were not scorched, which means they will survive despite the damage. And the ground was not nearly as impacted, meaning the soils remained intact and the seed bank was able to respond. And finally, in my hierarchy here, I want to also point out that each and every one of us has a role to play to learn about the fire-prone environments in which we live and to learn how to be adaptive in our own homes and to engage in programs like the Fire Smart program that engages, that educates us about how to reduce the risks through small changes in our lives at home. So to summarize, we can be coexisting with wildfire, but it's going to require substantive changes across a whole range of components of our society and all of society approach, from diversifying forest and fire management to engaging with Indigenous people to embed their knowledge in a revised landscape level forest management plans, to think about resilience and proactive or management in order to increase resilience of our ecosystems and communities. And that will require also education and engagement, even through programs like Fire Smart, where each of us can take small actions at home and contribute to the broader good of our communities. I've been asked by the media a few times if 2023 is a wake-up call. I thought we woke up in 2003. I thought that again in 2017 and 2018 and 2021. So I can't say more emphatically, our forests and communities are not resilient to climate change. Transformative change is urgently needed if we are to coexist with wildfire. Thank you.
Uh, 15 minutes for questions.
Yes. Oh, did you want to moderate? I'm not sure if you just want me to go ahead. And I don't know if anybody has questions online. Yes, go ahead. Yeah, so the question is, as the Ministry of Forests, is there an assessment of our landscape to determine where the wildfire risk is? Yeah, so we do have at the provincial level, there's been some fantastic work looking at the condition of the forest, historical ignitions, the fire weather regimes around the different parts of the province. And so we do have a sense of where wildfire risk is highest. Unfortunately, there's millions of hectares, tens of millions of hectares that are in the high category in British Columbia. And in part, that's due to natural processes, but also because of these cumulative impacts of change to fire regimes and land management over the last century. And so we almost have to take a triage approach. We do know that picking, identifying which components of the landscape, which components of the province have the greatest risk and the most people, we're investing in those programs in the wildland-urban interface, those communities, those forests immediately surrounding those communities to mitigate fuels and try to reduce chance of fire spreading into those communities with devastating effects. But that won't be sufficient. We really need to think at that landscape level. And so I'll reiterate that changing our forest management practices are critical. After 20 years, we treat less than 10,000 hectares per year on that proactive mitigation of fuels around communities that we know are at high risk. On the flip side, the forest industry is still harvesting 150,000 hectares of forest per year. So 15 times the forests in British Columbia are being impacted by timber harvest for sustained timber yield, but contributing in some ways to the problem of landscape resilience. So the provincial government has made a commitment to change to landscape level planning so that we have coordinated efforts across landscapes so we can begin to think more strategically about where we should have broadleaf forests or forests of different ages and structures and fuel types, or even parts of the landscape that should not be forest in future, that need to be the wetlands restored or the grasslands reinstated or the open forest as opposed to closed dense canopy forests. So there is movement afoot to get there, but quite frankly, I'm a little worried about how slowly we have been moving so far and how much time is estimated to begin to make those plans and implement them. There's many things we can do in the interim. Yes.
I'm wondering about that 10,000 hectares. What's the cost of restoring, like in that experiment, that 2021 one?
Yeah.
We're sending, 4,000 firefighters this year, I think you said.
Yeah, we've spent $4 billion in 2017, 2018, 2021, and 2023. Not sure what the price tag is, but we're going to be over $4 billion to try to put out fires in those 4 years alone.
Surely.
So there's a reaction, right? When we're under an emergency situation, we seem to have unlimited funds, and we do have unlimited funds, or we would be losing more communities trying to stop those fires. But the corollary has to be, we have to invest substantively into the proactive mitigation. And quite frankly, we haven't done enough of that. The Union of BC Municipalities has lobbied the provincial government again at their meeting here in Vancouver this week. And so there's a commitment to double the amount of proactive mitigation we've been doing. But we're really at about $500 million in 20 years compared to the $4 billion we've spent not putting out fires in these extreme fire seasons. And that's not meant in a disrespectful way to the BC wildland firefighters who are out there. Some of them who are on their 8th deployment have not had time off with family substantively since the beginning of May. But the fires today exceed suppression capabilities in all of our technology. We're fighting a different type of fire than they did in 2003. Okay.
It's coming from Thomas Martin, who's asking a question about the magnitude of management needed. It says, putting aside changes to forestry management, what's an adequate target in terms of hectares per year for fuel treatment, including different burns, mechanical, and treatment?
Oh, Thomas, thanks for making me come up with a number on the spot here. Yeah, that's a great question. And I'm not sure I can give you a number. I do know that from our work with communities, that communities, Indigenous communities and municipalities throughout this province identify fire as their #1 concern, that many of those communities know that they are surrounded by many, many hectares of forests that need to be treated. And it does require a really major shift in thinking of how we will live in these landscapes. And there's a tremendous cost. The question about how much does it cost per hectare, on average $5,000 per hectare to thin out those understory trees, leave your overstory trees to provide the shade. It's a costly endeavor. There's no money to be made, or very little money to be made from those understory trees. They don't contribute to our timber economy. It can't produce 2x4s, it doesn't produce others. This is where the innovation that comes from the bioeconomy and alternate uses of the fiber from those trees is so critical. And I'm so proud to have colleagues in the Faculty of Forestry who are on the global leading edge of some of that innovation. But Thomas, thanks for asking me, put me on the spot for that one, because I can't give you a number, but I can tell you it needs to be 10 times faster than what we've accomplished in the last 20 years, or we'll be in 2043 looking back and wishing that we'd made a change in 2023 that we didn't make in 2003. There's a couple more questions here in the room. How about over here? And then I'll come back to the side.
Yeah.
Yes, great question. So what we have seen, or what has been measured, is that for every 1 degree Celsius increase in temperature, there's about a 12% increase in lightning. So what we get with warmer temperatures is more volatile or more energy in air masses, and we see that contributing to the creation of pyrocumulonimbus clouds during fire, cumulonimbus weather events, and the types of weather systems that generate lightning. So these lightning outbreaks, they're now called, account for much of the fire emergencies, wildfire emergencies we've witnessed in recent years in BC. 2017, it was a lightning outbreak during a cold front, a dry cold front that brought lightning but no rain, that ignited hundreds of fires in the central interior of BC, which led to the record-breaking season of 2017. Similarly, in 2018, and I was astounded by the counts of 33,000 lightning strikes over one weekend in July of this year that ignited 200 fires over one weekend. We simply don't have enough resources. That swamps our ability to get firefighting crews out to all of those fires, even when they're in the locations in the landscape that put communities and values at risk. That's a lot of fire to try to address simultaneously after such a weather event. So lightning will be a serious concern moving into the future as well. And there's one more here.
Back to your point of forest management seems to be something that's still driven by the immediate need, like the growing deadlines and those sort of things. Seems so pressing for them. So can you talk a little bit about how strategy to respect that?
Yeah, so for people who may not be familiar with some of those terms, the question was around the pressure on the licensees to kind of meet the requirements of free to grow, which means when you harvest a patch of forest, you have to replant trees, you have to replant to a prescribed set of species that are kind of optimal for that site, and then also to densities that will regrow a closed canopy forest that will produce trees at maturity that could again be harvested to produce timber. And we've aimed in BC to try to make sure that we're kind of optimizing, and I'll go as far as to say maximizing timber yield over much of our timber harvesting land base. So in much of the interior BC, we plant lodgepole pine. It's really hardy. It can deal with the temporary droughts, the frost, the other things that happen in a large opening of a clear cut. They grow rapidly. They're part of an early successional sequence of trees that naturally grow after disturbance. But we also know that we make choices like brushing or using glyphosate-based herbicides to remove competing vegetation to give those conifers a leg up. And we want them to grow quickly. And we measure that success. And then once they have made it to a critical density and height so that they're free to grow, they will regenerate into a forest that can be harvested in future. We do almost no management of those patches of forest until the time comes to reharvest them. So we're not stewarding our forests with intensive management any longer, but we do have this system that is in place that produces timber yield. And I think there's our problem. We're working with a system that was established in the 1950s and 60s and 70s to optimize the economic benefit from those forests without realizing the unintended consequences of those actions. And quite frankly, the forest industry is hurting as well. Trees are not regenerating successfully in the warmest and driest parts of the province. They're not regenerating in these huge burn scars that are left after these massive fires. And so rethinking this framework that we have, rethinking not only at the patch level, these rules about free to grow and what to do and what not to do in these stands over time, but thinking at that landscape scale to reconsider how we're configuring harvested and non-harvested patches on the land, allowing the diversity of broadleaf trees and mixed forests and conifer forests to greater components on the land, I think will be essential. Because if we don't have that broadleaf component, we're removing some of the resilience from the land as well. So unfortunately for the forest industry, I think there's still more cost coming ahead of them. And we've been seeing that already. Timber supply issues in the coast from the fall down effect, the midterm timber supply after mountain pine beetle. We've seen a whole series and succession of mill closures around the province as our forests are unable to sustain the type of harvest that we had in previous decades. So I would like the forest industry to continue. I think that's the heart and soul of many of our communities in the interior of British Columbia. But to have our cake and eat it too, we have to change the way we're managing those forests because none of us are winning right now.
Just time for one more, and if I can let Andrea read that.
Okay,
She'd like to ask herself a minute.
okay.
See if this will work. Andrew, do you mind trying to speak now?
Yeah, can you?
Oh,
yeah.
it's a bit echoey.
Do you mind
Okay,
muting
yeah.
yourself?
Toyek thank you so much, Lori, for the talk. I was just really noting as you were sharing that there's such a deep parallel here with what we see in fisheries where selective, sustainable harvest methods were constrained and outlawed through colonization. And now we see federal and provincial governments wanting to turn back to these gears, these methodologies, these bodies of practice for sustainability solutions. And myself and many partnering First Nations find this super frustrating, this desire for solutions like weirs and traps and all of these brilliant technologies that we've developed across millennia without having that reckoning with the history and present of dispossession and criminalization. And so I'm curious to know, is that a frustration that's shared here too among community partners that you work with? Is there a reckoning happening in the forestry world? Thank you.
Yeah, what a powerful question. Thank you, Andrea, for asking that. I think we do see, I mean, clearly we live across almost all of British Columbia on unceded territories where we've not listened nor respected the Indigenous knowledge and that those multi-generational millennia of knowledge on the land. I've worked with multiple First Nations communities and I've heard from them their disappointment in the condition of their traditional territories, of the changes to the forests, of the understory plants, of the wildlife on which their lives depend. That's their food security, that's their sovereignty. Those are their traditional practices. Those are their existing. Traditional always implies to me like it's something of the past. And I want to make it clear that this Indigenous knowledge exists today, has been carried forward, and those practices are still on the land, albeit often constrained. We talk in British Columbia and in Canada about reconciliation, and there is lots of discussion within the Ministry of Forests about ways in which land is going back to communities, allocation of land for forest management back to communities. That occurs in multiple ways and is planned to increase in the coming years. And so that, I think, holds some promise, but it also creates uncertainty, which also is in an important mix or important for us to consider, because being respectful of Indigenous knowledge and Indigenous ways, while I'm also proposing solutions to address a century of land use change. I'm not sure that what I am proposing will always be consistent with what the communities and my collaborators and partners would like to see on their lands. So I'm hoping that we will find ways to respectfully be able to move forward, to be able with Western science to partner with Indigenous knowledge holders. And as I learned from Dr. Ron Ignace, who's a former chief Kukpi of the Skeetchesen First Nation, he had a concept that he taught to our research group that's called walking on two legs, where we walk together, Western scientists with Indigenous knowledge holders, that we work together towards goals, not that are defined by our Western questions, but are defined by the keepers of the land, by the Indigenous people. And so that we work in concert with them, but it is with the leadership of the Indigenous leaders whose territories we are allowed to work and collaborate with. And so I don't think that quite answers Andrea's question to its full, but it's an approach that we are in the steep part of the learning curve to try to adapt our science and to be respectful and to move forward in what we hope will be meaningful and fruitful solutions to these really dire problems that we face in British Columbia.
Which one is all the time we have, but let's give another round of applause.